Hey everyone, it's time to go ahead and work on your midterm practice test. So we have all the topics we've covered for the whole year. And so let's go ahead and get started. Question number 1 says, what is the domain of the graphed relation? Well, domain, remember, are your x values. And in order to figure out the x values from this graph, it's going to be helpful if we write down each of the points. So I'm going to go through and I'm going to write down the ordered pairs and mark it off as we go. So I'm going to start with this ordered pair. Remember, in ordered pairs we have x and then y. So to get to this first ordered pair, I go left 3 and down 2. Left is negative and down is negative. So that ordered pair is -3, -2. And I'm going to put a check. My next ordered pair right here, remember it's the over number first, that's -2. And then up 0, so -2, 0. My next ordered pair is over 0, but then up 1, so 0, 1. My next one is to the right 2 and then down 1, so right 2 is +2, down 1 is -1. And my last one is right 4, up 3, so +4, +3. Now again, the domain values are your x values. X is first in your ordered pair. So I'm going to go through and I'm going to mark all my first values, -3, -2, 0, 2, and 4. And typically you'll see these listed in order from least to greatest. So if we look at this, our x values, -3, -2, 0, 2, and 4. And some of these answers look really similar to each other. D is not going to be the right one. There's a whole lot of extra numbers there. Let's go through our others and see how they're different. So A, -3, -2, 0, 2, and 4. That looks right. B, -2. Oh, we start with -3. It's not that. C, -3, -2, 1, 2, 4. So because of that 1, we have a 0. That's not right. So our answer will be answer choice A. All right, number 2, the explicit definition of arithmetic sequence is as follows. That's our equation. It wants us to write an equation for this arithmetic sequence. Now, when we write our equations for our arithmetic sequence, we need a couple things. We need our first term, and we need our common difference. Well, it's telling us here our first term is 8, and that's also the first term in the pattern here. So we're going to go ahead and start filling this in. Instead of this A1, I'm going to put my first term, which is 8. Now my n minus 1 is going to stay. I just have to figure out my D, my common difference. In arithmetic sequences, these are just patterns where we're adding or subtracting the same number each time. Well, in this case, the numbers are getting smaller. That tells me we're subtracting. So to get from 8 to 5, I have to do -3. To get from 5 to 2, -3, 2 to -1, -3, -1 to -4, -3. That tells me that -3 is my common difference. So typically when we have it at the end there, we do write it in parentheses just to show that's being multiplied by a negative and it's not actually subtraction. So out of all these, I'm going to start with my first term. My first term is 8. A and D both have a first term where it's -3. Those are not going to be our correct answer. The difference between C and B is that in one, we have a -3 as a common difference, and the other, it's positive. Well, we know that our common difference is a negative, so I'm going to circle answer choice B. All right, question 3 wants us to find the value of the expression 2x squared times y if x is -1 and y is 3. This is just an evaluating expressions problem. We're going to take our x value, this -1, and we're going to substitute it for x. And we're going to take the y as 3, and we're going to substitute that for y. So I have 2 times whatever x is squared times y. And again, we said x is going to be -1 and y is going to be +3. Now, in order to simplify this, we need to follow our order of operations. So order of operations tells us we need to look at our exponent first. So right here, I have negative 1 to the second power. That means, since the negative 1 is in the parentheses, that means negative 1 times negative 1. Well, negative times a negative gives us a positive. Negative 1 times negative 1 is positive 1. So everything else I kept the same. Now, all we have is multiplication. When we follow our order of operations, we're going to multiply and divide in order from left to right. So I'm going to start on the left with this 2 times 1. 2 times 1 is going to give me 2. And then I have just 2 times 3, which 2 times 3 is going to give me 6. This one would be one that's not multiple choice. You just type your answer into the blank. Okay, number 4, which graph represents the solution to this inequality? Well, in order to know which graph is going to represent our solution, we need to actually solve this first. When we solve inequalities, we solve them just like we would solve equations. So whatever we do to one side, we have to do to the other. And the whole point is to isolate your variable to get that letter alone. My variable here is x. So the first thing I'm going to do to both sides is I'm going to subtract 3. 3 minus 3 is going to give me 0. So I'm left with 2x is greater than 9 minus 3, which will give me 6. My next step, I'm still trying to isolate that variable. This is 2 times x. I'm going to do the inverse operation, the opposite. I'm going to divide both sides by 2. 2 divided by 2 here will give me 1x, or just x. And I'm going to bring down my greater than sign. 6 divided by 2 is going to give me 3. So I have x is greater than 3. Now there's a couple things we need to look for here. Since we just have greater than, we don't have the equal to part. That tells us we're going to have an open circle. So because of that, we can eliminate answer choices B and D. They both have closed circles. The numbers greater than 3 include numbers like 4 and 5 and 5.5 and so on. Those are numbers that are to the right. This is indicating numbers, these are all numbers smaller than 3, so those are not going to be our answer. We're looking at answer choice C, which is showing all these numbers that are bigger than 3. All right. Sorry for the weird view here. Number 5 is another evaluating expressions problem. It says if a equals b squared minus c, all divided by 2, find the value of a when b is 2 and c is negative 4. So we're going to be plugging in. We're going to substitute 2 for b, and we're going to substitute negative 4 for c. So I'm going to rewrite this. We have our b squared minus c, all divided by 2. And this will all equal a. Now for b, that's my squared, I'm going to substitute 2. And for c, I'm going to substitute negative 4. Now our order of operations tells us that we start with our exponents in this scenario, because our parentheses here are just really used as just separating off those numbers. So 2 squared is going to give me 4. Now in this problem, this division sign, this fraction bar, is actually serving as a grouping symbol. It's splitting things into a top group and a bottom group. So we actually need to do everything that's on top before we do what's on bottom. Now in the numerator in the top, we have 4 minus negative 4. Minus and negative is just the same as plus. That's really 4 plus 4. So all I did was I rewrote it there so I can see it a little bit clearer without this minus negative. Now let's go ahead and actually add it. Again, we're doing the numerator there first because that fraction bar is acting as a grouping symbol. So 4 plus 4 gives me 8. And then 8 divided by 2 will equal 4. So A is equal to 4 in this situation because that's what we get when we evaluate that expression. All right, number 6 wants to know which of the following is an example of an equation. Well, we have equations, we have inequalities, we have expressions. We've got some of each of those in this problem. So the difference between an equation and expression, an equation has an equal sign. An expression Does not. And then we get into inequalities. Those have their own special symbols like less than, greater than, less than or equal to, or greater than or equal to. So if we go through and kind of look at each one of these, or the number 1 here has an equal sign. We call that an equation. Number 2 has an inequality symbol. This is our less than or equal to. That is an inequality. And number 3, there's no sign at all. That's an expression. Oops. Now, the question here is asking which of the following is the example of an equation. That's answer choice number 1. And so we have 1 only, 2 only, 3 only, or 2 and 3. Well, the only equation we have is A, which is 1 only. Number 7 asks, what's the solution to this inequality? Okay, I have negative 6x minus 17 is greater than or equal to 8x plus 25. Now remember, again, when we solve inequalities and equations, we have to do the same thing to both sides. So I'm going to look at my variable with the lowest coefficient, and that's going to be that negative 6x. So to get rid of that, I'm going to move that to both sides, or add that to both sides, I should say. Negative 6 plus 6 is going to give us 0. So we get negative 17 is greater than or equal to 8x plus 6x is going to be 14x plus 25. Now all my x's are on one side, so I'm going to have to move the numbers to the other side. So the opposite of plus 25 is minus 25. On the left, I've got two negatives. If I have negative 17 minus 25, that's the same as negative 17 plus negative 25. So 7 plus 5 gives me 12. 1 plus 1 plus 2 gives me 4. And since they were both negative, it stays negative. Now, again, I'm still trying to get my x alone. So in order to get rid of that 14, that is 14 times x, I need to do the opposite, and I'm going to divide both sides by 14. Whoops, dropping my pens. All right, dividing by 14. So in this problem, I'm left with negative 3 is greater than or equal to x. Now, really, we want to change it and write so x is first. And the point was pointing to the x before. We need to keep it pointing to x. That would be our answer. Now, you could solve this same inequality in multiple ways. Let's say I did it in a different order. I'm going to start, and I'm going to actually subtract my 8x first. That was a positive 8x. I can subtract it first. Now, negative 6x minus 8x is negative 14x. 8 minus 8 gives us 0. Now I need to move the numbers to the other side, and I can do that by adding 17. Negative 17 plus 17 gives me 0. So I'm left with negative 14x is greater than or equal to 42. I'm going to then divide both sides by negative 14. And I'm going to get x and negative 3. Now, there's a rule here. Whenever you multiply or divide by a negative number, you have to flip your inequality sign. So instead of the big side pointing that way, it's going to point the other way. Notice how we got the same answer both ways. We got x is less than or equal to negative 3.